Glad you've joined us for the session, Administering Your Enterprise Geodatabase Using Python. Jill and I are product engineers at the Geodatabase team from Esri. Jill is the Python GP person, and as she does her demos, you will know why. As mentioned in the plenary, the focus of our teams is to develop Pro and new functionality into it. So show of hands, how many of you are trying to administer geodatabases using desktop? Most of you, okay. Anyone in here transitioning to using Pro for administering? Okay, one person, two, great. So pleased to let you know that all the demos Jill will be doing today is using Pro 2.1, which is released and it's available to you. But the scripts that she is going to use can be used with both desktop and Pro. So those of you who are still using desktop, you will still have something to take home with. But we're hoping that when you get back, you will try to transition and see how these workflows now apply in Pro. That's our hope for you guys. I know this, so far, a lot of information has been put out, and the next 60 minutes is not going to be any different. We have a lot of content to share with you guys, so I'm hoping that all the questions will be kept to the end. Both of us are available after this session, and we've also brought our cards. So if we do not have answers to your questions, shoot us an email. When we get back, we will reply back to those. Transition. So as we prepared for this presentation, we made some assumptions. First is that you have some basic knowledge of Python, and you're here to learn a little more about it. You know what a geodatabase is and have some knowledge of enterprise geodatabase workflows. And of course, you're here for the slide and the code, which we will share at the end via link, and you can keep, so now for the next 60 minutes, just sit back and listen to us. We've divided this session into 3 sections. First is we look at the geodatabase just as an admin would look at it, and what are the contents of it. Then we'll talk about creating an enterprise geodatabase, users, roles, applying permissions, and also talk about the schema operations we do. Then we'll break off into version maintenance, the reconcile process, user management, seeing who's connected to your geodatabase, how do you disconnect these users. There's a lot of demos throughout this session, but we'll start with a few basic demos, and then we'll build up on the concepts. As Jim mentioned in the plenary, right, Python is cross-platform. So all the scripts that we showed today can be run both on Windows and Linux. With Python, you can take advantage of programming logic like looping or cursors. You can also integrate third-party functions within your script that Jill will show in her demo. It's also a great way to automate some of the workflows that you do on day in, day out basis. For most of you, a geodatabase is a container where you store your data, you load your data in it. It works as a scalable storage platform for your geographic data. It's also an information model when you are working with behaviors like networks, domains, and subtypes for modeling real-world GIS data effectively. If you have workflows that require versioning, replication, you can think of the geodatabase as a transactional model that governs the rules that apply to your workflow. When we talk about the geodatabase, we really talk about 2 distinct sets of tables. The first one, called the geodatabase system or repository tables, is basically metadata in the geodatabase that stores information about the contents of your data. It also stores information that is maintained at the workspace level so that it can be applied to multiple data sets. For example, versions and domains. The types of operations listed here are the ones you are going to perform on the system tables as the administrator. The second type of tables are the user-defined tables, and these are most probably the tables you see when you connect to a geodatabase from ArcGIS client. You may have tabular data, feature classes, or other type of data sets. The administration operations that you do on this data usually either changes the state or the structure of the data. You could do schema changes, right, such as adding, renaming, or deleting fields, granting and revoking privileges, and also enabling additional geodatabase behavior on the data. In order to manage all these tables, we have 3 different types of administrator: the database administrator, geodatabase administrator, and the data owner, also known as the dataset administrator. Now, based on your organization, this may or may not be the same person. It could be multiple people or the same person wearing all the 3 hats. Anyone here wearing multiple hats in your job? Yes. I can hold my hand up too. In today's demo, Jill will be demonstrating workflows from each of these different roles. So, a quick profile on a database administrator. Right, this is the person responsible for installing your database platform on the server, responsible for the user management and regularly backing up your database, always keep the system secure, and performance monitoring. This is one of the very important aspects of their role in an organization. But our recommendation is that all the 3 administrators, then you need to collaborate to maintain an efficient system. Geodatabase Administrator is the user that owns all the system tables that I spoke of earlier. And because they own these system tables, this user has some unique roles and privileges in a geodatabase. They can edit any data that is registered as versioned, they can view and reconcile any version, and they can compress the geodatabase. The data owner is the person who loads data into the geodatabase or creates new data. Modifying schema of data tables, or what was referred to as user-defined tables in the previous slides. They are also responsible to enable geodatabase behavior on the table, such as registering a table as versioned, enabling or disabling archiving, enabling editor tracking, and such as these. To connect to any of these as any one of these administrators, you do need a connection file. The connection file is how you access your database. It determines who and how you are connected. So when you connect to the database, you provide a username. That's the who. So depending on who you're connected as, you may be able to perform various operations that I mentioned earlier. Connection files also define how you are connected to the geodatabase, like what version or a historic moment that you want to connect to. If you want to connect using different connection parameters, you need to create a new connection file with different parameter values. When using the Python API, the .sde connection files are needed to access your enterprise geodatabase. In order to make these connections, we use the Create Database Connection tool. This creates a connection file that allows you to connect to your enterprise geodatabase or enterprise database, as seen in the screenshot. Some of you have used these connection files before, but created them through our catalog or the project pane in ArcGIS Pro. The Create Database Connection geoprocessing tool gives you a way to programmatically create these connections. Now let's switch to our first demo, handing it over to Jill to show us how to create a connection using Python.
Hi, can you guys hear okay? So my name is Jill. I'm going to be doing the demos today. All the demos, as Annie mentioned, are going to be in Pro, and Pro uses Python 3. So I just wanted to mention that. So first of all, I want to show you guys a pretty simple intro demo. I want to show you guys the Create Database Connection tool that Annie just mentioned. So I'm going to demo that tool in Python, and once we've created that connection file, I'm going to show you guys some arcpy describe functionality. So first, let's take a look and see what this tool looks like in the geoprocessing pane. So I can search for it, create database connection. So here you can see there are a number of parameters. We have a file location, the file name, and then we have a bunch of database specific parameters. So I don't know if you guys are familiar with working with GP in Pro yet, but one thing you might notice it's a little bit different from ArcMap is if you, the GP pane is actually contextual. So you'll see a lot more parameters when you open this up in ArcMap. And in Pro, since it's contextual, once you start typing, it'll add parameters that are required as you go and remove them as you don't need them. But instead of doing this in the UI today, I'm going to go ahead and do this in Python. So I start here. Oops, the wrong one. Create database connection. So as you can see, there is some contextual like IntelliSense here. I was able to just choose that tool as I was typing, and then we have a pop-up here which is going to show us the parameters that are needed as we go. So the first parameter is the output folder path, so I'm just going to drag and drop that as the first parameter. Next we provide a name for that connection, so it'll be demo1. Next we get to choose which database platform we want to connect to. So as you can see, we have a ton here. Some of these, this is a combination of geodatabases as well as databases. In this case, I'm going to select SQL Server. Next, I'm going to provide my instance name. Then I need to decide the account authentication. So this is going to be whether I want to use database authentication, or if my database supports it, I can use operating system authentication. So since I'm connecting to SQL Server and I've configured it to use operating system authentication, I'm going to go ahead and choose that. So that means I won't need to provide a username or password. It's just going to use my Windows credentials. Next, I can decide whether I want to save that save my username and password with the connection file or not. And then finally, I'm going to choose the database. So you can see it's taken a little bit of time. This tool is actually connecting to my instance and finding the geodatabases that I have permissions to and listing them out here. So we'll connect to demo1. Sorry about that. And as for the rest, I'm just going to leave those as default. So while that's running, I do want to show you guys, well, actually, let me restart that. When this tool runs, the result you see, you get a path here. So in the Python script, you would take that path and be able to use it in other tools as you're running. So before we get back to the slides, I'd mentioned arcpy describe as well. Do many of you guys use arcpy describe? Forgetting a few people? Okay. So it's really useful when you have a dynamic input. So let me bring up the help topic for that just to quickly look at it. So the arcpy describe function has a workspace properties that you can get from an SD connection file. The reason why we're looking at workspace properties is because an SD connection file is seen as a workspace. So there are a few different properties you can get from these files. So when you have connection properties, things like what database you're connected to, whether it's a geodatabase or not, the connected user, things like that, as well as whether it's the current release, you can get a list of domains, etc. So let's take a look at trying one of those out on that file I just created. So here I'm using the connection file, connection properties, and I want to see what database I'm connected to. So I know, well, we know that I entered demo1, but there's some other things that we could check as well, like what version we're connected to. Since I didn't specify that in the connection file tool, I can check that out, and we connected to the default version. Another thing that might be useful is whether the database you're connected to is the current release. So you can see that as well. In this case, I am connected to one that is the current release. I'm now going to give you guys back to Annie.
Great. Thanks, Jill. The next set of slides are going to be a list of operations that each administrator is responsible for. We hope that as you listen to all the workflows that each of the role is responsible for, you realize what a valuable asset you are to an organization, especially if you are the person wearing those multiple hats. So if you're starting from scratch or you do not have a spatial database in your setup, then you can use the Create Enterprise Geodatabase tool to create a brand new geodatabase. Or you have a setup where you want to fully automate the creation of geodatabase for setting up testing environments. The database administrator will be the person to create the new enterprise geodatabase, as you need additional privileges to create the underlying database before creating the system tables in it. Once you have your geodatabase created, you're probably want to have people access to the geodatabase. In order to do that, you will need to create new users in your geodatabase. Most of the database administrators would be more comfortable creating users directly in the database, but if there is a scenario where you need to create users through the ArcGIS client, we have a tool for you. The Create Database User tool creates users with privileges to create data in the database. This differs from platform to platform, but is well documented if you are curious to find out specifically what privileges are needed. And I have shared the Pro Help link for that. One thing this tool will not do is create the Geodatabase admin user, as this requires greater privilege than what is allowed by the tool. Going right along with creating users, you can also create database roles. This makes it really easy to assign and revoke privileges to a number of users at a time. So rather than iterating through and assigning privileges to individual users, you can group these users into roles and apply privileges to many users at a time. We would recommend creating roles first so that as you create new users, you can assign them to these correct roles. We will see this in the next demo. And this is also done by the database administrator. The other way to create an enterprise geodatabase using Python is use the Enable Geodatabase geoprocessing tool on an existing database. Maybe you have a database with spatial data, permissions all set up, and now you want to take advantage of the geodatabase functionality that we have to offer. You can use the Enable Geodatabase tool to lay down the system tables to convert your database into a geodatabase. This tool needs to be run by the Geodatabase Administrator. Back to Jill now to show us how to use Python to create an enterprise geodatabase.
So in this demo, what I'm going to be doing is I'm going to be going through creating an enterprise geodatabase in a SQL Server instance. Then we're going to create a role and create some users. But before I get started on that, I want to show you guys first the Enable Enterprise Geodatabase tool that Annie just mentioned. So I have it open here. This is a pretty simple tool. Your input would be a connection as a Geodatabase Administrator, and then you would provide an authorization file. Since that's a pretty simple tool, I'm not going to demo it here. I'm going to get into creating that enterprise geodatabase instead. So this is going to use the Create Enterprise Geodatabase tool. Again, you can see the parameters as I'm typing here. The first parameter that's required is the database platform. So I'm going to be using SQL Server in this instance. Next, I provide the instance name. So in this case, it's just the name of my computer. I'm going to provide a name for the geodatabase, so demo2. Next, for the account authentication, I need to provide my credentials as the DBA user. So whatever user has permissions to create a database. In this case, I can actually provide operating system authentication since I have my database configured for that, meaning I won't need to provide a database username or password. It's just going to use my Windows credentials. Next, for the schema, I can decide on an SDE schema or a DBO schema. In this case, I'm going to use SDE, but depending on how your organization is set up and what security configurations you guys have, you could use either or. Whatever works best for you guys, I guess. Next, we have Geodatabase admin name. So this is going to be the Geodatabase user, or administrator, I should say. Sorry. So I'm going to have that named SDE, and I'm going to provide a password, highly secure password of SDE. Next, we have the table space name. So this is an optional parameter that you may use if you're on Postgres or Oracle, but in SQL Server, we don't use that. So I'm going to go ahead and skip that. And then finally, we need to provide an authorization file. So I'm going to drag and drop that here. And this is just a license file that gives me the ability to create a geodatabase. Just going to run that and get that going. Have many of you guys actually used Pro before in GP and kind of getting familiar with? Yeah, a few people? Okay. So when you're in desktop or ArcMap, you might notice when you run things in the Python window or GP, a window usually pops up and gives you some messages. In Pro, that's kind of in a different place. So we just ran this tool. Normally, you would see a few messages pop up when you're running that in desktop. In Pro, after it runs, you can go to the catalog pane, to the history tab, and here's where you see the information, kind of like that results section in desktop. So here, when you hover or if you click, you can see the input parameters that are used and a bunch of messages that are returned. So this tool, it checked the user credentials that I provided to make sure the user had privileges to create database objects. It created the database, it validated that authorization file, and then it did a few other specific things for SQL Server. So now that we have our geodatabase created, let's go ahead and create a role to go in there. So the arcpy, create role. So for this tool, I'll need to provide my credentials as the DBA user. So I've already created a connection file. I'm just going to simply drag and drop that here. I'm going to call this role editor. So that was quick. Now that we have an editor role, let's go ahead and create some users to add to that role. Here I want to create a number of users at one time. You could do this using a list or a dictionary, but since you want the option sometimes for your password to be different than your username, I'm going to use a dictionary in this case. So we can go ahead and create that dictionary. Oops. So I'm going to create 3 users. It's going to be Tom, same password, Matt. Sorry, this is tedious to type out. And Colin. Oops, I have a... Okay. So we've created our dictionary. Now let's iterate through that dictionary and create each user. So for user, password in user dictionary, dot items. We're going to call the create database user tool. Again, we'll need to provide our DBA credentials. Next, we decide what the authentication type will be. So again, we have the option of operating system user or database user. In this case, these are database users. So I'll provide the username and then the password. So that's coming right from that dictionary. And then finally, we'll assign them to the editor role. So that was an easy way to quickly add a number of users at one time. Again, we can go to the history and see those users were created. Let's go inside of SQL Server Management Studio and take a look at what that actually looks like. So we can see that our Demo 2 geodatabase was created. Then I can navigate down to the roles, and we see here is our editor role was created. If you check the properties, we can see that Colin, Matt, and Tom, all three of those users were created and added to that role. And that's it for the second demo. Back to Annie.
Yes, you have a question?
Yes, so the question was that I created those users using my, yes.
And you are an SA.
Yes, I am the SA user for SQL Server. If it was Postgres, it'd be the Postgres user. I don't remember what the user is in Oracle, just the sysadmin, right?
Yeah.
Yeah.
But
yeah,
anyway,
so,
these users need to be created by the database administrator.
Without a safe user, you can create but it's what they call, but they decided to.
Right, yeah. So yes, without being the DBA, you cannot run this tool. Mm-hmm. Yeah, as SA.
Yeah.
Yes, as SA. All right. Thanks, Jill. That was great to see how operations that were done at the client side affected the underlying database. Moving along, once you've created your enterprise geodatabase, you want to start loading data into that geodatabase. We have numerous tools for creating data in your enterprise geodatabase. You are probably going to be familiar with these. Many of them start with the word create. So as listed in this slide, we also have tools for loading data. When you use these loading tools, you will need to be connected as the data owner user. Once the data is loaded, you want to manage privileges on your data to determine who can access it. You do this using the Change Privileges tool. This tool will take a list of data sets and allow you to grant or revoke either view or edit privileges. When you grant view privilege, the user can select contents from that table. When you grant edit, the user can insert, update, or delete contents from that table. You must be connected as the data owner to perform these functions. That was a short break for Jill. So now giving it back to Jill to put it all together and show us how to, go through this whole workflow via Python.
I just turned off my mic. Yeah. Okay, so for this demo, I've already created a Python script, and we're going to go through a number of tasks here. Oh, whoops. I'm sorry. Thank you. Now you can see what I'm talking about. So for this first demo, we're going to go through a standalone Python script. Before I get started, I want to mention the program that I have opened. So this is the IDE that I like to use. It's called Wing to debug my Python scripts. But this script could be run in any other development environment or idle or whichever you guys prefer to use. So in this script, we're going to go through a few things you've seen already and kind of add on top of that. So we're going to create a new enterprise geodatabase. We're going to add users and roles. We're going to load some data and then apply permissions to that data. So first of all, at the top of my script here, I have a few things to start with. These are just some local variables that I'm assigning. We're going to be using these throughout the script, so it's just easy to have these at the top. First thing we want to do is create that enterprise geodatabase. I'm going to go ahead and get that started. So like we did in the last example, I'm providing the necessary input to get that created. And again, I'm going to be using SQL Server. Another thing I want to note is that I'm using print statements here. So if you're not using a debug environment, you'll find it really useful to have these. So if you're automating the script or you just don't have the ability to stop and make breakpoints, if something goes wrong in the script, at least you can kind of see, what was it trying to do last if you can't figure it out from the error message. So now that our geodatabase is created, I'm going to create a connection as the DBA user. So in SQL Server, this would be SA. Now that we've created that connection, I'm going to create a role called viewers and then a role called editors. So we've created those roles. It's quick. Again, we're going to create some users to assign those roles. In this example here, I'm using lists instead of a dictionary, so kind of use whichever you guys prefer, whatever works best. So it's going to loop through and create all those users and assign them the roles. And finally, I'm going to create one last user, and this is going to be my data owner user. So I won't assign that user any roles. So now that I've created that database owner user, which is the GDB user, I'm going to create a connection as that user. And then finally, I've connected as that user. I want to load some data. So the tool that I'm using to load data is called import XML workspace document. Basically, I've used the export XML workspace document to migrate my data from one geodatabase to another. So now that we have our data loaded, I'm going to use arcpy's list tables, list feature classes, and list datasets to compile a list of data that I just loaded in there. And we're going to use that data list to change the privileges on the data. So what I'm doing here is I'm using the change privileges tool. We're going to give users in the viewers role privileges to query the data, and we're going to give privileges to the editor's role, full editing privileges. So again, I'm just passing in that list that we created to do that. Takes a minute. The next thing that I'm going to do now that all my permissions are assigned is I want to register each data set as versioned. So I'm reusing that same list, and I'm looping through each list in the, each data set in the list and registering as versioned. The last thing I'm going to do here is I'm going to create a private version for each user in the editor role. So here I have my list of editors from earlier when we created the users. I'm going to be able to loop through there. I'm going to create a connection as that user. And then I'm going to create a version, a private version from each of those connections. So I'll let that run through. One thing you'll notice is I have this clear workspace cache tool that I'm calling here in the middle. Since we're reusing that same SD connection file each time, it's a good idea to use this tool just to avoid any caching issues. And that's it for the Python script. Let's go take a look and see what that looks like in Pro. So I'll go to my demo3 folder where I just created these 3 connection files. In Pro, in order to drill into your SD connection files through a folder, you actually have to add it to your project. So I'm just going to add these to the project so we can look in there. This is going to go to my databases folder. So I'm going to connect as the data owner, so that GDB user. So if I right-click some of my data, I can go to privileges dialog, similar as in desktop. And I can see my editor's role has full editing privileges, my viewers have select only, and then we also have the SDE user, which is our Geodatabase Administrator, and they have full editing privileges, and this is because the data is registered as versioned. Another thing I want to look at is those versions that we created. So now I'm connected as the SDE user or the Geodatabase admin. We can open up our versions view. The reason why I'm doing this from the admin is because I do have access to see all the versions connected. If you were to connect any of these specific users, Matt, for example, you would just see only the version that they own, since the access is private. So again, we can see those versions and the owner and the access. That was all created through Python. And that's it for this demo. Back to Annie.
Thanks, Joe, for that comprehensive demo. Right, we're going to switch gears now and talk about version administration. We're going to focus on the reconcile process, updating statistics and indexes. We're also going to look at managing user connections through Python. First up, we're going to talk about why we might want to disconnect users. Maybe you have some users that are connected to your geodatabase and they've gone home for the day or they're on vacation and they have locks on your data and you need to do some schema changes to the data. Or maybe you're the DBA who needs to perform some maintenance on the server. Or there are just some large queries that are being run and you do not want these connections that are just idle to use up resources. we have multiple functions for managing user connections. First is the accept connection function. You provide an admin connection and a Boolean value as parameters for this. True means new connections to the enterprise geodatabase are allowed, and false means new connections are blocked. So if the parameter is set to false, currently connected users will not be abruptly disconnected. They can continue to work in their session, but when they try to make a new connection or start a new session, that will be blocked. The second function is the list users function. This returns information that you can use to ask questions about who is connected to the geodatabase. Finally, the last function we have is to disconnect user functions. This allows you to disconnect users from the geodatabase by passing the ID that was returned from the list users function, or you can simply use the keyword all if you want to disconnect everybody. How many of you here are publishing services, like using the WebGIS model? Okay. Every year we see more and more hands, which is a good thing. You know, we want to push our data out there. In this case, the services we are talking about are published by reference. So feature services where the data is not copied over to the server, but it references the data in your enterprise geodatabase through a connection file. Services, they connect as a regular user. The geodatabase does not know that there is anything special about this user. So if you disconnect everyone from the geodatabase, this would include any services that are making a connection. And an ArcGIS server has logic that will attempt to reconnect stale connections. Because of this, you should block your connections before you disconnect users, especially service users. So ideally, the workflow would be you block connections, stop your service, perform your admin workflow, then you accept connections, and then start your service back. So if you do not stop your service or block connections, you may see some strange behavior, such as partial drawing or errors in your server log, or just failed queries for that matter. Handing it back to Jill to show us a cool demo on how to manage connections.
So in this demo, I'm going to be showing you guys the functions that Annie just mentioned, the accept connections, list users, and disconnect user. In this demo, I'm also going to be using the Jupyter Notebook to give this. Usually I do this in the Python window as well, but I thought I'd change it up this year and experiment with this. So I have this Jupyter Notebook. It's going to be alongside, I have Pro open over here as well. We're going to take a look at how running these functions affects Pro. So you can see I've added a few connections as a number of different users to Geodatabase. So I'm going to go over here and run my script simultaneously. So the first thing I want to do, since I'm running this outside of Pro, is I'm going to import arcpy, and then I'm creating a variable that's going to just basically store my the path to my Geodatabase admin connection file. Next, for whatever my workflow is, I've decided I want to block new connections to the geodatabase. So we're going to use this accept connections function. We're going to pass in our GDB admin credentials, and we're going to set the value to false, meaning no new connections can be created. So now the experience in Pro, now if I try to connect, say as Gary, if I try to connect, what happens is I can't see my data. If you're in ArcMap or desktop or even Python, you might get something different, like an error message, something like that. So now that I've blocked any new connections to the geodatabase, let's see who's still connected. So to do this, I'm going to generate a user list using list users function, and I'm going to be providing my GDB admin credentials. So as you can see, I printed out that list. There's a ton of information returned. So you have your connection time, client name, the username, the user connection ID, tons of information. So you can see we have a number of users connected. This is kind of messy, it's hard to really look at, so I'm going to clean this up. We're only really interested in the username and user ID. So we can see that we have a feature server user connected, Brent, Colin, Craig, and the SDE user. And the SDE user is actually our own connection that we're using to run this function. So I happen to know that Brent is on vacation, and he must have just accidentally left his connection open by accident. So let's go ahead and disconnect Brent. So what I want to do this is use disconnect user function, again using my GDB admin credentials. And now I need to enter Brent's specific connection ID. So this ID is always going to be different. Every time you take it down and the user connects again, they're going to have a different ID. So let's run that. Now I'm going to regenerate that list and see who's still connected. So as you can see, Brent is no longer connected. I was able to disconnect him using that function. So as Annie had mentioned, sometimes you may want to disconnect most users, but you don't want to disconnect the user that is connected to your feature services. So here's an example of using a list comprehension to disconnect all users that I specify, or all users except for the ones I specify. So I'm going to share. I know it's a little hard to see here. This is going to be shared at the end as well. So I'm going to have a list to disconnect. So I'm going to get the user ID for each user in the user list. If the username is not SDE, so we don't want to disconnect ourselves, we'll get an error, or the feature server user. And I've added a print statement just to make it look a little prettier. So as you can see, we have the IDs pulled out for Craig and for Colin. So now let's iterate through that list and disconnect those users. Again, I want to regenerate that list and see if we were able to disconnect them. And as you can see here, now we just have the feature server user as well as SDE. So now I would do whatever tasks I wanted to do while I had everyone kicked off. Just always remember at the end to use accept connections to set that back to true so that users can connect again when you're finished. And I'm going to send you guys back to Annie.
I think that was a cool demo. And we saw this at the plenary, and I pinged Jill and said, hey, can we change this up a bit? And she took up my challenge, and she did it. So I'm pretty impressed. So just continuing with the theme of responsibilities, but now we're going to switch gears and talk about versioning workflows. We perform reconcile and post to push and pull changes between different versions in the geodatabase. In Python, we use a reconcile versions tool. We recommend that you run this as the Geodatabase Administrator in an automated maintenance routine, only because this user, as Jill showed, can see all the versions in the geodatabase. It's just much easier to write a script when you know the connected user can view all the content that you have to work with. Compressing your geodatabase. Right? You can run the compress tool to trim the states in your geodatabase and also clean up records from the Delta table. This also needs to be run as the Geodatabase Administrator. We always recommend that you update statistics after you reconcile your data, but this also holds true for any major data changes. So if you're appending a lot of data or performing a lot of edits, it's a good idea to update your statistics and indexes, which helps ensure that the geodatabase is performing well. This can and should be done by your Geodatabase Administrator to update the statistics on the system tables, especially after reconcile or compress, and also done as a data owner on the tables that they own. Now that being said, databases now have excellent inbuilt mechanism to detect if the statistics and indexes are stale. And if your SQL Server, with the most recent one, they also do a rebuild for you. So it would be best to work with your database administrator to determine if a rebuild of indexes and statistics on tables are required. They can actually just generate you a report which tells you which of these are stale and which needs to be rebuilt. Back to Jill to show us how version management is done through Python.
Okay, so this is our final demo. I've written a Python script that's going to reconcile, post-compress, rebuild indexes, update statistics, and then we're also going to generate some email reports as well. So some of these initial tasks you guys have already seen, but we're going to kind of build on that and then add that third-party module, which is kind of cool. So first of all, again, I have some initial variables that I'm setting. These ones that I have highlighted here, these are a Boolean variable that I'm going to use throughout the script. So as Annie was saying, sometimes you may want to run these rebuild indexes and statistics, sometimes you may not, depending on what your setup is. In this case, I've set those to true, so I will go through that here, but if you guys are using this script yourselves, maybe you want to set to false or just remove it altogether if you're not using it. So the first thing that we want to do is use that accept connections, as we did in the last demo, and block any new connections to the geodatabase. Next, we want to find a list of users who are still connected. So the reason why we're doing that is that we would like to give those users a little bit of time to finish up and let them know that we're going to disconnect them from the geodatabase. So in this case, I've hard-coded my email list, but if you had a way to kind of match the connected user to the email, you can use this list to send out a warning. That's what we're going to do here. I'm just going to click past this to get it started. Network's a little slow here, so it takes a bit of time. But I will see an email from the Python administrator letting me know, you're connected. You're going to be disconnected in 15 minutes, so please log off. That should pop up soon, but while we're waiting, here is where you would set the timer. So if you want a 15 minutes, 20 minutes, whatever it is, you can enter that here. I'm sure you guys are getting hungry, so I'm not going to make you wait 15 minutes. We'll go ahead and skip through that. Okay, so here's our email. So this is an example of what you guys could use to do a similar thing. So next, now that we've let everyone know we're going to disconnect them, we can go ahead and use that disconnect all keyword. Again, you want to be careful about using the disconnect all keyword in case you do have those feature services on there. One thing I did want to note is that if you do accidentally disconnect your feature service user, there is a setting on each of the services that gives you kind of a time frame for how often they're going to try to repair those. So I think the default setting is every 30 minutes the server tries to repair those connections anyway. You can change that if you need to. Next, we're going to use list versions function, and we're going to provide the admin connection, and I'm going to go through and get a list of versions in the geodatabase. And then again, we're using a list comprehension, so we're going to get only versions where the default is the parent. Next, I want to, once I have my list of versions that I want to reconcile, I'm going to call the reconcile versions tool. So I'm running this as a Geodatabase Administrator. It's a nice, easy way to do it since I have privileges to all the versions. This is an automated way to reconcile your versions, so you do have to define how you want to resolve, define your conflicts and resolve conflicts. So basically, if there's any conflicts that you find, do you want to stop the operation and go inspect them yourself, or do you want to just carry through? Another thing that this tool gives us is an output log. I'm going to get that started. So this is kind of, the tool generates a report and lets us know what the tool did. So we're going to open up that log and start appending that to a message that we're going to email ourselves. Along with that reconcile log, we're also collecting our own messages here, so kind of making a little bit of a custom message as well as that log. Next, we want to compress. So we're going to do compress. And then we're reaching that Boolean value. So here I said, yes, I do want to rebuild indexes and statistics. So let's step through that. The first thing we're going to do is use Rebuild Indexes tool. We're providing our admin credentials, and we're going to be able to run that tool on the system table. So these are, we're building indexes on the repository tables. Next, we're going to update statistics using Analyze Datasets, again on those system tables. So now that we've finished our tasks as our GDB admin user, we're going to allow users to connect to the geodatabase again. And next, we're going to do some tasks as the data owner, so the GDB user. In this case, I wanted to show an example where you can use arcpy describe to get some of the connection properties. So here I have a path to a connection file, but I didn't create that connection file. So I'm able to use the connection properties describe to see the connected user, or to get the connected user. And the reason why I'm doing that is because I want to use this in a filter when I'm using list tables and list feature classes to get data sets that are only owned by that user. So for example, I think list tables or any of these listing functions would return a list of feature classes or tables that you don't own if you had editing privileges. So I just want the ones that I own. Now that I have that list, I'm again going to run those rebuild indexes tools, rebuild indexes and analyze datasets tools. This time, since I'm connected as a data owner, I'm going to pass in my owner connection. And then I'm going to say no system, so these are on the actual data tables themselves. So I've passed in my list of tables to run these on. So we're rebuilding indexes. You can see it takes a little longer. There's a little more data than the repository tables. And then analyze data sets. Again, not on the system tables, but on the data itself. Then we're going to use all those strings that we built up throughout the script that has our messages, whether things failed or passed, or not passed, or successful, I guess. So we're going to send ourselves another email. I can look into the way that I did this was by using a third party, so like just a built-in module that comes with Python. So I wrote a little function here. I believe it's called smtplib, this here. So this is the module that you would want to use, and I provide what is needed. So you might have a certain server that you need from your own. Okay, so that's finished, and the email should come in shortly, but while we're waiting for that, I want to show you guys how you can truly automate this stuff. So it's great that I was able to sit here and click through the script and see how this works, but that requires me actually being at my computer and doing that. So a really great thing about Python is that you can automate these things to run while you're not at work. So here's our email. So as you can see, these are some of the custom messages that I added through my script. Here is the reconcile log that we got from the tool. So everything was successful, but if there were any errors, you would get that there as well. So to truly automate this, what I want to do is I want to use Windows Task Scheduler to run this script at a time I'm not at my desk. If you guys are on Linux, you can use a cron job for this. So what I'm going to do is I'm going to create a basic task. I'm going to call this run reconcile. What I want to do is I want to run this weekly. By weekly, I really mean Monday, Wednesday, Friday. If you are disconnecting users, it is a good idea to run this at a time that there are not going to be many users connected. So I'm going to go at 3 a.m. What I want to do is I want to start a program. And the program I'm going to start is, it's going to be the path to my Python executable. So in Pro, this is in a slightly different place than desktop. And then the argument that I want to add is going to be the path to my Python file. Before I finish, I want to open the properties dialog to change a couple more things. So here I want to choose to run this whether the user is logged on or not. Likely you're not going to be logged on at 3 a.m. So it's a good option to use here. And then we want to run with the highest privileges so there's no problems there. So we need to provide a password. And then you can see my task has been added. So that'll run as scheduled 3 a.m. every Monday, Wednesday, Friday. I'm going to give you guys back to Annie to wrap up and get a link for all these scripts that I shared today.
Thanks, Jill. So takeaway from this is that the Geodatabase is open to Python developers. If you're looking to administer your Geodatabase, there are lots of options for doing it through Python and geoprocessing. When you just take a look at the data management toolbox, you get an idea of the plethora of tools that we have. We could not cover all of these in this session, but if you have follow-up questions on that, we are available to answer. Please use the Events app to find our session and fill out our survey. The feedback you provide is valuable to us and helps us to improve the session every year. So if there was anything specific you were looking for, let us know, and we can include this in next year's presentation. As promised, link to the slide and the code. So while you're all taking a snapshot of that QR code, we are available for questions. Thank you for being patient with us. We have 4 minutes before our 1 hour gets done. Yes, sir.
So the list users command lists all the users who are connected to the Geodatabase. Is there a way to list users who are connected to a specific table, a specific feature class with the Geodatabase, and just return that user?
So the question was if there was a way to list users that are connected to a specific table. There is not in Python. There is in the UI. There is ways to see that information, but in Python, unfortunately, there's not.
Yes, exactly. So the answer to that question is that you have to actually check the locks, because when you access a table, there are locks that are put in, and so you really can't tell from list users which users connected to which table, but you can always check the locks and see which user is holding on to a table. Yes?
So the illustration we saw was basically, it's an idea to do database maintenance, abstracting out a specific database engine. Because you can have different database engines, right? And the tools you demonstrated, they abstract out specific steps you need to do in each single version of a database management system. But in reality, if you are stuck with a particular system, you would actually do the same steps within that particular system itself. Let's say it's SQL Server, you can disconnect the user, you can do the maintenance steps, and such and such and such, just creating specific packages, SSS packages, for maintenance.
Yes, so the speaks like a true DBA, saying that everything that you showed me as an administrator, I can do it at the back end. And that is true, that has always been true. The reason we have all these tool sets on the client side now is because we heard from users saying, I need to be able to do simple administration from the client. I am unable to do that. I have this dependency and this roadblock where if the person DBA is not there, I can't do anything. And so that's the reason why we have these tool sets in the client side to do the functionality that you could always do on the database side. Yeah, you're welcome. Yes, sir. Oh, yes. Sir, the first row. So the question is, how do we use the Python functions to work with Active Directory? Because you saw Jill showing the username and the password. That will require certain other customizations. We can't talk to you post this. It's not a simple solution to just say, yes, you know that. Active Directory, there's a reason why we switch to Active Directories, because we don't want our passwords just out there in the open. Yes. Yes, sir.
Do you ever plan to provide scripting of the Esri database objects? So, say like a feature class and scripting it out entirely, the create fields, the set versioning, the subtypes, all that, so you don't so you don't have to manually build all those individually.
Excellent. So the question is basically data modeling, right? Can we have a script that just creates my feature classes, adds my fields, adds my subtypes, and all that?
Or at least be able to generate that script from an existing object.
And I want to say, yes, that is possible because we have tools that can do that for you.
I actually give a session at the user conference that goes through that. So if you go to that link, it goes to my GeoNet page, and I will have that information from last year's session on there if you want to take some of those scripts to play around with. They should be there.
Yes. So the question is there scripts to help me understand the health of my system, of my geodatabase? Can I ask what platform are you using? What database platform are you working on? SQL Server. Which version? 2012. Okay. This is where we were talking about collaboration, right? Your database has excellent procedures to tell you exactly the health of your system. And you would need to work with your DBA to generate that it's a simple report that they can give you saying what is the status of the statistics and the indexes. We currently do not have a script that can help you monitor whether your system is badly performing. See, you will see the symptoms of it, right? People will say, I'm trying to edit, or I'm trying to reconcile, or I'm trying to do, and things are just slow. And that is where at least that's a symptom that gives you an indication that performance is going down because maybe our statistics are stale or indexes have to be rebuilt. Yes?
To add on to that though, so that's fine for the database platform itself, has its own health monitoring capability. Is there a similar concept at the Esri level? Is there geodatabase health? It's not, and how would I map geodatabase health to underlying database health? Like, what would it be? The system tables don't have indexes rebuilt, or it's things that would only be at the Esri level.
So the question is that we talked about the health of the system at the database level, but if you want to go abstract it up to the geodatabase level, is there a way to monitor the health of the geodatabase? Currently, we don't have anything, but if that is something we really need, send us an enhancement request, and we can look into building maybe an app or something that will actually you'll be able to connect and say, as a geodatabase administrator, what is the health of my system? Okay.
Because there's a mapping there that I might not, as an experienced geodatabase user, I might not realize it. In order to see the geodatabase health or lack of health, I have to look at certain things that the database health.
Okay.
If I knew what those were, then I could just
Look at those. Okay.
But you're right, the extra credit would be to extract it at a
Higher level.
do that for me.
Yeah. So provide that in your feedback, as an enhancement, guys. This would be nice to have. Sure. We welcome those. Yes.
I actually have a follow-up question after this question, because from my understanding, a geodatabase as a universe of settings is, I don't really want to be like a fancy or something like that, but not really that enhanced. You feel really concerned with its health.
So we rely. Right. So we do rely on a very performant underlying database, right? We are just creating tables inside that in that database, right? And so as you pointed out correctly, is that there is not much we can do. If your underlying database is healthy, like the system tables is what we really work with, most of our stuff. You should have a performant system. But then depending on your versioning workflow, right, that's where you have multiple versions, there's a lot of edits in there. That's where we come into picture, where we could be, to query one thing, we have to do a join between those delta tables and the system tables. That's where we can slow things down. But there is, we like maybe are 20% of the problem, but there is a bigger issue deep down. But thank you for adding that. Yes, sir. Sure. But then that's what Jill said, right? There is a parameter set on the ArcGIS server to try to reconnect.
Yeah, it would try to reconnect, but since we have blocked the user.
Right, but then the people who are consuming that service will start getting weird behavior.
Yeah, okay.
That is the only reason. It is just for the, like when we publish data, right? It's not just for us to consume. It's for all those clients. And basically, when you block it and then you stop it, they just get that, URL, you can't find the URL. But if you do not stop the service, most probably it will start pinging and they will start seeing weird errors on their side. So it's only for a neater user experience, basically.
Another question is, it's DBA or whatever we saw. So the recalculate of statistics. When I talk to my DBA, they say, yes, we are recalculating the stats.
Okay.
And it's like, but we are doing sampling. Like 25%, we are using our ecospatial as a
Okay.
So they're saying, like, I asked them that, okay, are we doing like recalculating of statistic every night? So he's saying like, yes, we are doing it, and it's like 25%, and that is good.
Okay.
I mean, is it like, and here we are saying like, we have to do for user level, whatever, like, if we have a DBO and having like 10 version database, we have to do the recalculate stat of all those 10 tables, right?
Yes.
But
Your DBA is saying that.
what does that mean, like 25%? Would that be sampling of every table with 25% of records, or is it like?
So the question is, my DBA says the system is all performant. Let me ask you, do you see any performance issues when you're working?
Yeah.
You do.
Yeah.
What is the performance issues that you are seeing?
Feature services not rendering the data, slow rendering of the data, versioning, yeah, we are sometimes, a lot of performance, and that's altogether different. I don't want to say.
Okay.
Yeah.
So, and how often? So, I think we can talk offline. We just have to understand your workflow as to why you would be seeing this kind of performance issue.
Just wanted to understand actually that, okay, this sampling thing is, what we saw in the script, we are doing like, we recalculate stat, and we are giving like, another number. So is it like, sampling includes the data as I'm not very sure. Last one.
Okay, let's have the DBA maybe help us out with that.
This goes back to my very first question during the presentation. What security context you are doing that under? If you have rights to do that, yes, you will be able to do that. If you don't have rights, it really depends on what level, who are doing in that data.
Yeah, we do have, we connect as the, and we do.
SD is not there.
Sorry, I'm sorry. DBO, which has all the tables, is having the system
You don't have access to the compiles, or at least in SQL Server, you don't have access. Because in fact, there is a configuration where you configure SD one step below DBO. In fact, I talked to
Shannon?
Today, and she said,
Yes.
why this DBO is pretty here? It's not supposed to be here. I said, no, I know. So you actually have, even with SD, it is a little bit one level below DBO. And what you're talking about is at least one step above.
and we are doing that. The only thing is it takes a lot of time if I do it from ArcMap or ArcGIS to recalculate the statistic like days, because we have huge data, and I don't know. And when I ask DBA, they say like, oh yeah, don't do it from ArcGIS, we are doing it, and it's like 25% sampling and 50% sampling of them.
So, but then is the data refreshed every day?
Every day.
Oh.
Yeah, every day we have like n number of editors. We are from telecom, so it's like every day. So that's one small question.
Okay.
Editor you were showing the Python. So what editor is
The role. So the question is the editor that you mentioned in your, that's the role, right?
The
where
you mean the IDE itself?
yeah.
That was Wing.
Oh,
Wing?
Wing.
Yeah, Wingware, I believe is the longer name. That's what
Yes.
So
Yeah. There's a trial version.
we build a system index. What kind of a system index is built? So after first in like a child, reconcile from third parent to child, also post back to the parent. Right? So we need to rebuild the system index, right?
Yes.
So what kind of index is inside? What if before there's no index?
So the question is after we do a reconcile post, right? And then we're doing the rebuild index and stats. We're not building anything on the versions. These are only on the metadata tables, the system repository tables. Because when we do this whole reconcile post operation, there are, the SD lineages table, the different metadata tables that we work through to get your edits from the different delta tables into the base table.
But that has been done before build the indexing, right? From reconcile and also post.
Mm-hmm.
After compression, we mentioned that there's a build the index, right?
Rebuild index, yes.
Yes. So what does that mean?
What does that mean? That would be just what does rebuild index mean on the system tables, right? That's your question to me. So that is basically just updating telling the database that the next time you go to query it, you need to follow a certain pattern to get those queries back faster. Whatever index so you're asking me what the exact index is on the table.
Yes.
That I'll have to get back to you on that. What the exact index is.
So if there is no index, why bother build the index, right?
There will be index in the table already. So
If you look-
our case, when we have slow performance, we actually do the rebuilding of index through SQL Server in the backend.
Okay. From the client side.
Yes, right.
Yes.
And it also does the spatial indexing.
Yes.
Right?
Yes.
But still, we are still experiencing
Slow down.
performance issue. So that's where we have having.
But the spatial index is different since from
That's on the data, right? The spatial index is on your data. Yes.
We're talking about the system table, right?
Yes.
So what I'm asking, what specific system table, the index as they are.
Well, system tables are created often and they are not conformal. It's just basically like if we talk about like a regular operating system, it's like defragging your hard disk. You really need to make it because it hits the system tables all the time. So if they are not conformal, it doesn't really matter what's behind it. It's just everything will be very slow.
I know what I'm now starting probably is recover to the previous state of the system tables. After reconcile and post changes, back to parent version, right? So maybe that's what's my understanding. But the index is kind of confusing or missing.
Yeah, but share, you personally did that.
I know the system table just metadata, right? So if you rebuild the system index, you have to mean something. You just don't know, okay, we have to rebuild the index. Okay, right?
Well, if you change the data, it's a simple rule. Change the data, tell it it's
We should probably
Yeah.
take
We can
any
take
more
questions,
specific
yeah.
questions up here because I think we have to be.